What's up, everybody? This is Mr. Tui, creator of the SAT Crash Course series. And if you're looking for help with the digital SAT math test, I've got you covered. In this video, I'm going to teach you the easiest and fastest way to solve questions from the math section of Digital SAT Practice Test 1, Module 1. And if you like this video, make sure to like and subscribe down below, and be on the lookout for more digital SAT videos coming out soon. In the meantime, enjoy these answer explanations from Digital SAT Practice Test 1, Math Module 1. We got another question up on the screen here. We got question number 19. Little geometry here. Go ahead and read question number 19 for us, please, Tanner.
Circle A has a radius of 3n and circle B has a radius of 129n. Where n is a positive constant, the area of circle B is how many times the area of circle A?
Woo! Okay, all right. So one of the interesting changes here on the digital SAT is the geometry questions. A lot of them are not drawn to scale. In fact, I haven't seen any that are drawn to scale just yet. And a number of them here, they don't even give you a figure. They just kind of describe it. And so you're going to have to solve a geometry question here without a figure. Now, the first place I want to start is I want to go to rule number 3, actually, on that rules document. You've got access to that, Tanner?
Yeah.
Go ahead and bring up rule number 3. I want you to read that for us, please, loud and proud. We'll discuss.
For geometry problems, always draw a picture of the figure described in the question. You have to conceptualize the question the right way before you can solve it.
All right, great. Let's go back to the question here on the whiteboard. So we're just going to have to draw a picture of this here. So we got two circles, and one has a radius of 3n, right? That's circle A. And then circle B has a radius of 129n. So it's significantly bigger here. Could you draw a couple pictures of these circles? Could we see these? It doesn't have to be like perfectly to scale or anything like that, but like I just want to see some pictures of these circles and get a sense here of what's going on here in this question. So just find a clear spot on the whiteboard and start drawing. Let's see what happens. All right, there we go. All right, so we've got a couple circles here. Now notice, so the first circle, the radius is 3n. So I'm just going to add a little n there.
Oh,
and the other one is 129n. Now, I mean, if these were drawn to scale, the 129n one would be like a lot bigger. You know what I'm saying?
Yeah.
Like even bigger. This will work for right now, right? We're still kind of thinking about it the right way. Clearly, the circle B is bigger, and we know significantly bigger than circle A. Does that make sense so far?
Yeah.
Okay. I'm going to label these circle A and circle B as well, just to kind of keep track of everything. Okay. All right, so now I don't think the operation here is obvious to find out how many more times, the area of circle B is bigger than the area of circle A. I don't think that's obvious at all. So what I want to do is I just want to plug in a value for n, okay? And we'll find out how big the radius is for each of these circles. Once we know the radius, I think we can find the area of these circles as well once we have a value for n. Does that make some sense?
Yeah.
Okay. I also want to point out that they give us, on the digital SAT, they give us a lot of the formulas that you need, especially when it comes to geometry, at the beginning of each module. And do you know right off the bat, do you know the area of a circle formula? Are you familiar with that?
Pi multiplied by r squared.
Yeah, so the area, I'm going to make a note of that here on the whiteboard as well, equals pi r squared. But they give it to us in case you don't know this or you don't remember it for the test. Let's go to the beginning of Module 1 here real quick. And at the very beginning of the test, before they give you the questions, they give you these formulas here. You're going to have access to this when you take the test. And then do you see that there in front of you, Tanner? You see the area of a circle formula?
Yeah.
Yeah, this guy right here on the left-hand side. So there it is. In case they also give you the circumference of a circle there, area of a rectangle, area of a triangle. We got Pythagorean theorem as well, special right triangles, bunch of stuff. We'll reference those kind of as we answer the questions as well. But right now we just need that area of a circle formula. Okay, so I'm going to set this value for n. Let's just make it 1, man. Let's make it 1. If n is 1, what's the radius of circle A? If n is 1.
Yeah.
Well, that's a question. What is the radius? If n is 1, what's the radius?
The radius is
because right now it's 3n, but if n is 1, the radius of circle A is 3. So I'm just going to put a 3 there.
Yeah.
Okay. And then of course the radius of circle B, if it's 129n and n is 1, it's just 129. So I'm just going to put 129 there for the radius of circle B. Now we can find the areas of each, right? Just using the area formula. Okay. So let me see you find the area of circle A. We'll start with that one first. Go and work this out on the whiteboard. Just plug in the radius, really. That's all we're doing here.
Yeah. Oh,
That's a pi. I got it. That's good enough. That'll work. All right.
Multiplied by 3 squared.
3 squared, right? And we're only squaring the 3 here, right?
Yeah.
3 squared, of course, is just 9, so it's just pi times 9. Here you've got x. We could leave it as 9 pi. We could, or, it's a calculator section. We can just do 9 times pi. And I think most students are probably more comfortable with dealing with decimals than they are with pi. So let's just multiply 9 times pi. And what does that give us?
28.274.
Yeah. So I'm going to make, yep, there you go. You already got it. 28.274. All right, so that's the area of A. And then the area of B, let's just do the same thing. Once again, we're just squaring the 129. That's going to be a big number. And then multiplying that by pi. So let's do that. I'm doing it on my calculator as well.
It's a very big number.
And a very big number, yeah. What is that number?
It's 52,279.
Yeah.
Point
0.24, yeah. So I'm gonna fix that 9 a little bit, make it really clear here. Okay, 52,279. So all we got to do here is find out how many times bigger the bigger one is now. Okay, do you kind of see the operation here we can do to find out how many times bigger it is, or no?
Division.
You could just divide the big one by the small one, right? The area of the big one by the area of the small one. Or we could also multiply the area of circle A by the answer choices. That would work too. But if you see the operation, we can just divide them. We'll get it faster. So let's do that. I'm just going to divide that by that big number, 52,279. Divide it by 28.279, right?
274.
274?
Yeah.
274. Okay.
Yeah. 1,849.
Yeah, there it is. There's your answer. Questions about that?
No,
that's not too bad, is it? Once you kind of see it, you know what I'm saying? Just reading the question is really confusing, and the path isn't super obvious. But draw a picture, start there at the very least. But then once again, that first rule of plugging in values to the variables comes in real handy here, because you can actually figure out what the area is, as an actual number, not just in terms of n. And I think that clarifies a lot. So, any questions before we move on? Or are we good here?
No.
But draw a picture. You got to draw a picture on these geometry questions. All right. Great job. Let's keep on rolling. Questions are getting a little bit harder here toward the end of each of the modules. Although this one's actually not too bad. Do you see that question up on the screen?
Yeah.
Okay. All right, and go ahead and read question number 20 for us, please.
The frequency table summarizes the 57 data values in a data set. What is the maximum data value in the data set?
Okay, what are we solving for here? Let's focus on the question right now.
The maximum data value.
Yeah, the maximum data value in the data set. And they give us all the data values. You see where that is here?
Yeah.
Right, just on the left-hand side of that chart. That's it. The tricky part about this question thing is really realizing how easy it is. I know I was just talking about the questions getting a little bit harder, and they tend to toward the end of the test, but this one's really, really easy. I mean, just look at it, Tanner, and tell me, what's the maximum data value in that set?
14.
It's 14. And that's your answer. It's 14. Any questions about that?
Very easy.
Really easy.
No.
The tricky part is just realizing how easy that is. You think you got to do something with the frequency. Oftentimes you do, depending on the question. But this one is just literally understanding the question, looking at it, and seeing what the biggest value is. Any questions about that, or are we good?
No, we're good.
Okay, awesome. Okay, this one's a little bit trickier. We got an equation of a circle question here on the xy axis. Go ahead and read number 21 for us, please.
A circle in the XY plane has a diameter with endpoints 2, 4, and 214. An equation of this circle is x minus 2 to the second power plus y minus 9 to the second power equals r to the second power, where r is a positive constant. What is the value of r?
What in the heck are we solving for here, Tanner?
The value of r.
The value of r, right? Which is right here in the equation.
Yeah.
And that's the equation of the circle then. Now, first, look, you just have to know the equation of a circle on the xy axis. Okay, you just have to know. There's not a ton of equations you have to memorize for the SAT, especially because they give you so many equations. We just talked about that on a previous question, that area of a circle question. They give you a bunch of equations for area and formula and stuff like that. But they don't give you this equation for a circle on the xy axis, and you have to know it, okay? Now, I've got a section here on my rules document, so I want to go to that real quick. Open up that rules document you've got access to. And let's scroll down together to Basic Concept O. Basic Concept O. This is equations you need to know. Okay? And you should see there on Basic Concept O the equation of a circle on the XY axis. Do you see it there? It should be the first one on the left-hand side of that document. Do you see it?
Yeah.
Okay, good. All right, I want you to read that for me. Read the equation of a circle. I'm just going to kind of copy it here on the whiteboard so we've got access to it while we're solving this. What is the equation of a circle on an XY axis?
It's parentheses x minus h parentheses and then to the second power plus parentheses y minus k parentheses to the second power equals r squared.
R squared, yeah. And that's where r is the radius of the circle. I want to make that really, really clear. R is the radius of the circle. And then h comma k is your center point of the circle. It's not actually on the circle, right? It's kind of the bullseye in the middle of the circle. I'm going to make a note of that as well. You got to know what the h and k values mean. Okay. And the nice thing about the equation of a circle, if they give you the equation of a circle, which they essentially give us here, of course, we don't know the r value. We're going to figure that out in just a minute. But if they give you an equation of a circle, you know the center point because you can just pick out what your h and k values are. And if they give you the radius, then you know what the radius is. And you can draw it. Okay. Now, they give us our h and k values here because they give us most of the equation of the circle, but they give us the left-hand side where we can draw out our h and k values. So could you tell us what our h and k values are? What is our center point for the circle? Start with that h value. What's the h value in this case?
2.
It's 2. Now, a lot of students will say negative 2 because they see, but it shows up as x minus 2. And it's like, it does. But because the equation is x minus h, if h is positive, it's going to show up as x minus that number, x minus h. If h were negative 2, it would show up as x plus 2. Does that make some sense?
Yeah.
It's a little bit tricky, but be careful of that. Keep your h and k values straight and watch out for those negatives. What's our k value?
K value is 9.
The k value is 9, positive 9, right? And I know it shows up as y minus 9,
yeah.
But again, if k is positive, it shows up as y minus that number. So we know our center point, it's 2 comma 9. Does that make sense so far?
Yeah.
Okay. We could draw this on the xy axis. We could find this point. Okay, in fact, we're going to need to. So I'm going to draw a little xy axis sort of just to the right of this question here. I think I'll have space to do this. There's a wobbly little xy axis. It should work. Okay. And, okay. So I want you to find the point 2 comma 9 on that xy axis. Can you find that for me, please? 2 comma 9. We'll find the center point here for the circle.
It's going to be kind of up there.
Close. You're real close. That'd be 2 comma 10-ish, I think. I'm kind of just looking at those grid lines on the whiteboard.
Yeah.
Yeah, I dropped one more space down on the y-axis.
Oh, that was a little too far.
Yeah, I'm going to help you out a little bit, Tanner, here. I'm going to help you out a little bit. I'd say it's this point right here is the point 2 comma 9. Look real closely at that.
Yeah.
Do you see why that's the point 2 comma 9? That's where the x value is 2 and the y value up there. Oh, wait. Yeah, I got it. Is 9 because that's 5, that's 10. So that would be 9 right there. Does that make some sense?
Mm-hmm.
Okay. All right. So, okay. Now they tell us that this circle has a diameter with endpoints 2, 4 and 2, 14. So could you show me where those endpoints of the diameter are? Let's find 2, 4. Let's start there. Real close. Do you know how to zoom in on the whiteboard? You can just, if you're on that iPad, you should be able to pinch in. Yeah, I'm gonna help you out a little bit. Just be a little more precise. There we go. Do you see it?
Yeah.
Yeah.
Oh, there were the little dots.
Yeah, yeah. There's 2, 4, and then the other endpoint is 2, 14. Can you find that?
Yeah.
Yeah, pretty good.
Right there.
There you go. Yeah, right up there. Just gonna mark that in blue. Okay, good. So there's our diameter. So we could draw this circle right now, roughly. You know what I'm saying?
Yeah.
Yeah, it looks something like this. I mean, I don't know exactly. Woo. A little bit wobbly there. But that'll work. That's good enough because we're solving for r. That's the radius. Well, do you see what the radius is? I mean, we can even draw it if we wanted to. What's a radius, by the way? What does radius mean?
6-ish.
Well, it's close.
It's the distance to the center.
Yeah, it's the distance from the center to an endpoint, right? So, I mean, here's the diameter. Okay, remember, the diameter is not the radius. The radius is the distance from the center point to an endpoint, any endpoint on the circle.
Mm.
So we can count how many units that is, right? Let's do it. Let's count it together. That's 1 unit, 2, 3, 4, 5. Okay?
Yeah.
And I think that's our answer. R is 5. The radius is 5. Does that make some sense, Tanner?
Yeah.
Why did you say 6? Was that kind of just a visual estimation sort of guess?
No, I counted from one of the sides and it was 6.
Oh, okay.
But it was an uneven circle.
Oh, gotcha. Okay, yeah, the wobbly circle there. Yeah, that's what I would count from the center point to the other point they give us. Does that make sense?
Oh, yeah.
Yeah. If you're counting, if you did it over here, and once they give you those endpoints, you should just realize it's 5 units from the distance from the center point to the endpoint. So maybe I could have drawn a more accurate circle, with 1, 2, 3, 4, 5 units to the left, and then 5 to the right as well. 1, 2, 3, 4, 5. Yeah, the one on the right's not too bad, but we could have drawn a little more accurate circle connecting those endpoints. Not a bad idea to do that, by the way. There you go. So that would have been more accurate. Does that make some sense?
Yeah.
Okay. But again, if you know the equation of a circle, it's just not bad if you know what all that means. H and K values are your endpoints. R is your radius of the circle. Any questions about that?
No.
Okay. Awesome. Yeah, don't be intimidated by those questions as long as you know the equation of a circle, but you've got to memorize it. And that's the case for all those 4 equations you need to know. They're on that rules document. You just have to memorize those. They don't give them to you. All right. Go and read question number 22 for us, please. Ooh, a radians question. Go and read it, please.
The measure of angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians greater than the measure of angle R. What is the measure of angle T in degrees?
What are we solving for here, Tanner? Good heavens.
The measurement of angle T in degrees.
Yeah, the measure of angle T in degrees. Yikes. Okay. My first question for you here, Tanner, is do you know what a radian is? Are you familiar with that term?
I'm not quite sure.
Yeah. Have you ever taken
I've heard
trigonometry?
it once or twice.
Yeah. Have you ever taken trigonometry?
No, I haven't yet.
Okay. If you're watching this recording and you know what radians are, then, great, you might know how to solve this. A lot of students, I'd say most of the students I work with at SAT tutoring just aren't familiar with radians, or they just don't know what it means. So let's take some time here to try to just understand what radians mean. Once you understand what they mean, this is not too difficult a question. But let's understand what it means first. I'm going to draw a circle here, just to the right of the question. And it's going to be slightly lumpy, but it'll work. Okay, we've got a little circle here. And I'm going to give it a radius. Right here. We'll call that R. Okay. And Tanner, I want you to imagine that radius is a piece of red string that we're going to lift up off the screen and kind of place around the curvature of the circle. Okay, so it's the same distance as R, same distance as a radius, but it's kind of like curving around the circle. Does that make some sense?
Yeah.
Does that look like the radius or R, roughly?
Mm-hmm.
Yeah, more or less. Okay. Now, if I connect that to the center point and I create an angle based on an arc of that radius, I want you to guess how many radians that angle is. Because radian is just a measure of an angle. How many radians is that angle? Take a guess.
25, maybe?
No, well, maybe it looks like maybe like 25 degrees. Actually, if I think in terms of degrees, it looks probably more like, I don't know, 60 degrees or something like that.
Yeah.
If you're familiar with how degrees work. So it's kind of a trick question.
Yeah,
because, yeah, that's right.
I looked in the
What's
wrong
that?
spot.
Yeah.
Oh, I was looking. I didn't. The grid was already there, so I could have used that.
Okay.
I
Yeah,
was kind of zoomed out.
Let me show you. This is 1 radian. 1 radian, because it's the angle you get from an arc of length 1 radius. So that angle is 1 radian. Does that make some sense?
Yeah.
Okay. Let's do it again. I'm going to add another sort of R length here, kind of placed around the curvature of the circle. Something like a radius there. It's close. And I want you to guess how many radians that angle in green. Hold on. Popping up on the whiteboard. Come on. Let me refresh my whiteboard here. There we go. I want you to guess how many radians that angle in green is.
Probably around 128. Well, no, 25. But...
Well, it looks like 120 or 125 degrees, but that's not how many radians it is.
Oh, yeah, radian.
Guess how many radians it is?
2 radians?
2 radians, man. You got it. That's 2 radians.
Right?
Right? You're starting to see how this works?
Yeah.
This is all radian is, right? It's a measure of an angle in terms of basically an arc of the length of, 1 radius arc would give us 1 radian angle, and 2 radiuses arc would give us 2 radians of angle. That's all. Let's do it again. I'm going to add another radius here. So there's another length connected to the center point. Guess how many radians that angle in purple is?
3.
That's 3 radians. You got it. Okay. Now, I'm going to give you a 180 degree angle here. 180 degrees. Okay, straight line. Okay. And this is where I think it actually gets kind of interesting with radians. I want you to guess how many radians 180 degrees is. And notice that it's just a little bit more than 3 radians. Can you guess how many how many radians 180 degrees is? That straight line.
Is it going to have a decimal in it?
Well, it could. It's going to have a pi in it. That's for sure.
Okay.
I'm just going to tell you. It's pi radians. 180 degrees is pi radians. Because basically, if you have a semicircle, of arc going around a circle, the angle formed by that semicircle, of course, it's 180 degrees. But that radius would go around pi times. So that angle is pi radians. Does that make some sense?
Yeah.
Yeah. Which also means that 360 degrees, right, which is the total number of degrees in a circle, 360 degrees is 2 pi radians. Does that make sense?
Yeah.
Okay. And I think they tell us this on the old SAT they did. I want to go to the digital SAT where they give us all the formulas. So let's go back to that, the beginning of Module 1. Yeah, and they do tell us this here. Go toward the bottom of that page. They tell us the number of radians of arc in a circle. Do you see that?
Yeah.
Okay, I'm trying to highlight this. That's not working. Okay, but anyway, but you see it. It's right there. How it says the number of radians of arc in a circle is 2 pi, right? Which is the same as 360 degrees. They tell us that just above that. So you know how many radians there are in a circle. You know how many radians are on 180 degrees as well, because that's going to be half of 2 pi. So that's worth knowing. It's going to be helpful here on this question. Is that making a little more sense what a radian is so far?
Yeah.
Okay, good. So here's what we're going to do. We're solving for the measure of angle t in degrees. And measure of angle t is basically, we're just adding up these two angles here in radians, angle r and angle t, right? Because angle t is 5 pi over 12 greater. Is that clear? We're just going to add those up. Is that clear?
Yeah.
Yeah. So we're going to add those up. We can just leave them as they are, like as fractions right now in terms of radians. And then we're going to convert them into degrees. Okay, I'm going to show you exactly how to do that. It's helpful to know that 180 degrees equals pi radians. That's kind of why I wanted to show you that and show you why that works. But first, let's add up these angles here in radians. So I'm just going to start by setting this up. So we've got 2 pi over 3 radians. We're going to add that to 5 pi over 12 radians. Okay. Now we got to talk about adding fractions a little bit. Do you know how to add these two fractions here together? Do you know how to do that?
Yeah.
Yeah. We gotta have a common denominator. So what's our common denominator going to be, Tanner?
12.
It's going to be 12. So how do we get a 12 in that first fraction on the left-hand side? In the denominator.
Gotta multiply by 4.
Yeah, got to multiply by 4, or more specifically, multiply by 4 over 4. Does that make some sense? Yeah, because 4 over 4 is just 1, so we're not changing the value of 2 pi over 3 radians. We're just kind of changing the way it looks. But if we do that, what do we get?
We get 8 pi on top.
Yeah. We get 8 pi. Don't forget that pi. We're going to need that there. So 8 pi over 12 radians. Let's add that to 5 pi over 12 radians. We're looking good. We're looking good, Tanner. Let's add these puppies up.
And that's going to be 13 pi.
Correct. 13 pi. Yeah, you deal with pi just like you deal with x, right? It's like 8x plus 5x is 13x. 8 pi plus 5 pi is 13 pi. Yeah, you're just adding the coefficients, that is the numbers in front of the pi, and you just leave pi there. Questions about that, or does that make sense? So
that makes sense.
Okay. And that's how many radians this puppy is. Okay. Now, we've got to convert that to degrees to find the right answer. Does that make some sense?
Yeah.
Yeah. But first, I wanted to, before we even do that, I want to take a look at this term here, this 13 pi over 12 radians. 13 over 12 is really close to 1. You know what I'm saying, Tanner?
Yeah.
Yeah. I mean, it's going to be a little bit bigger. Like 12 over 12 is 1, but 13 over 12 is just a little bit bigger than 1. So that's basically pi radians. I mean, it's just a little bit bigger than pi radians. Does that make sense? Well, that's just going to be a little, just a tad bigger than pi radians. Does that make sense?
Yeah.
Yeah.
It's going to make sense.
And you know how many degrees pi radians is. How many degrees is pi radians? Now you know. How many degrees?
180.
180. So the right answer has to be just a little bit bigger than 180. Does that make sense, Tanner?
Yeah.
What do you guess right now? If you just had to guess, what do you guess the right answer is?
Probably C.
Yeah, probably C. I'm going to make a note of that here. That's our guess right now. We're going to confirm that here in just a moment. Okay, I don't have the answer key in front of me at the moment, but we're going to find out. Let's convert that into degrees now. But right now, 195 is your best bet. It just makes sense logically. It's probably, come on, 390 degrees? That's bigger than a circle. That doesn't make sense, right? And 120 is less than half as well as 75 is less than a quarter of the circle. And this thing is probably closer to, it is just a little bit bigger than 180. Let's convert it. So let's talk about unit conversions now. Unit conversions. Have you done unit conversions before? Do you know what that means?
Yeah.
Yeah. We can convert 13 pi over 12 radians into degrees by multiplying by a fraction called a unit conversion. Now, the units we want to go into degrees. Do we put that in the numerator or in the denominator of the fraction?
Denominator.
No, it's the other way around. The unit we want to go into, we put in the numerator, actually. And I'll show you why here in just a moment. So we're going to put degrees in the numerator, and we're going to put radians in the denominator. Okay? The reason why we're going to put radians in the denominator and degrees in the numerator is that just like you can kind of cancel out terms if you have the same term in the numerator and denominator, you can also cancel out units. So the radians here, we've got radians in the denominator, radians in the numerator right there. The radians are going to cancel out. We're just going to be left with the degrees. Does that make sense why the unit you want to go into, you put in the numerator? Does that make sense, Tanner?
Yeah.
Yeah, okay. Now, as long as the value of the degrees up here equals the value of the radians, we're good. And the reason why that works is that, again, anything divided by itself is 1. So when we multiply by, that unit conversion, we're just multiplying by a form of 1. We're not going to change the value of this fraction right here. We're just going to change the form. We're just going to change the way it looks. Okay? So tell me, how many degrees are there in a radian, or how many radians are there in a degree? As long as they're equal, we're good.
Number of radians in a degree be like 65 in a radian, or would it be?
Yeah, well, that's true. In one radian, it's around that, right? It just looks like that, kind of based on the picture up here, right? Yeah. But like, let's be more specific. We can be a little more precise, right? Again, as long as the value of the degrees equals the value of the radians, we can put anything there. So we've got a couple options. We could do 360 degrees in 2 pi radians. We could do that. Does that make some sense why those two values are equal?
Yeah.
Yeah, we just talked about that. And again, they give you those values at the beginning of each module. So we could use those terms. I'd rather use smaller values. We could just do 180 degrees, and pi radians in the denominator. Does that make some sense?
Yeah.
Okay. Let's multiply these guys out. But before we do, let's cancel some stuff out first, right? We can cancel out the radians. Those are gone. What else can we cancel out?
The pi.
We can cancel out the pies.
Maybe.
Yeah. No, definitely, dude. We got a pi in the numerator, pi in the denominator. It's all multiplication. We can cancel those pies out. And then now, we could maybe divide 180 by 12, or we could just multiply this thing out, right? Do you remember how to multiply fractions? Like we were talking about previously. Yeah. We just multiply, you got the calculator, so let's just multiply this stuff out. 13 times 180, and then 12 times 1, basically. That's just going to be 12. So let's start with 13 times 180. What's that equal?
2,340.
2,340 divided by 12, and this is going to be degrees because we're left with just the degrees right here. What's 2,340 divided by 12?
195.
Booyah. We could confirm it there with the calculation. Okay. Now, on a time test, I might just pick 195, right? Once you realize that, like, you've got 13 pi over 12 radians, and you realize that's just a little bit bigger than 180. The others don't make a ton of sense. But if you need to calculate, and there might be some questions where you actually do need to, convert radians to degrees or degrees to radians, go through that operation with the unit conversions. Does that make some sense?
Yeah.
Okay. I've got a spot on the cheat sheet as well here for converting back and forth between radians and degrees. I want to go to that real quick just to kind of show you where it is on the cheat sheet.
Okay.
And this is a basic concept Q. Basic concept Q. So I want you to scroll down to that. Let me know when you're there on the cheat sheet. Basic concept Q.
Yeah.
Okay. And then you see, to go from radians to degrees, you're just multiplying by 180 degrees divided by pi radians right there. And that'll give you the degrees. Or if you need to go from degrees to radians, right, the unit you want to go into, again, you put in the numerator, we'd multiply by pi radians over 180 degrees. And that'll cancel out the degrees, just leave you with the radians. Does that make some sense?
Yeah.
Yeah. So even if you've never studied trigonometry before, and I work with a lot of students that really haven't, or at least didn't pay attention during trigonometry, they're just really not that bad. It's just unit conversions, really, is all it is. But I think it's helpful to kind of know what radians mean, and that'll help you conceptualize the question a little bit more. Any questions about that one?
No.
Yeah, definitely a higher level difficulty question. Definitely. But again, just knowing that we're dealing with something a little bit bigger than pi radians, that gives you the answer. So not too bad if you look at it the right way. Great job there, Tanner. Let's keep it rolling. All right. I'm going to read question number 23 for us, please, Tanner.
A certain town has an area of 4.36 square miles what is the area in square yards of this town?
Oh, what
1 mile equals 1,760 yards.
Yeah, what are we solving for here, Tanner?
The area of the town in square yards using the square miles we were given.
Yeah, we're solving for the area in square yards of the town. I want to start, once again, this is a geometry question. Let's just draw a picture of this town. Let's start there. Okay. And you just make it a square. It should work.
Yeah.
Yeah, so we'll make a square town. We know the square miles. But go and draw a picture of this guy. And we'll start there. Yeah. Why not make it a square? There you go. Great. And we know the area is 4.36 square miles.
Mm-hmm.
So I'm going to make a note of that. Area is 4.36 miles squared. Okay. All right, and we got to find the square yards of this town. Now, this is a little tricky because like going back and forth between square miles and square yards is it's just not easy. It's not obvious. Okay, I mean, to go back and forth between miles and yards is much easier. We can just do the conversion units we've been doing, but it's a little different with square miles and square yards. So let's first convert the square miles basically into just like the dimensions of this town in miles. You know what I'm saying? Like,
yeah,
we can figure out like the length and the width of this town, which are going to be the same, by the way, because it's a square, right? The one we drew. First of all, do you know how to calculate the area of a square or any sort of rectangular figure? Do you know how to do that?
Yeah.
Yeah. What do you do?
To find the area of a square, you need to multiply the length times the height.
Yeah, the length times the height or the length times the width, right? Generally, is kind of how it's portrayed. They give that to you, I think, as well at the beginning of the module, in case you forget. But I think most students are pretty familiar with that. So let's come up with some values for the length of the square and the width of the square. Let's figure out what it is. And let's just make them, like we got some number times another number gives us 4.36 square miles. We drew a square here, so let's make them both equal. Does that make some sense?
Yeah.
Do you know how to calculate the length and the width here of this square town? Based on the area? You can say no if you don't know.
Remind me.
Well, I mean, like if the area is the length times the width,
mm-hmm.
and these lengths and widths are equal, then the length
both divide it by 2.
Well, you divide it by 2 won't do it, right? Because if you multiply those values together, I don't think you'll get 4.36. But if you take the square root of 4.36, that should give you the length and the width. If you take the square root. Do you see the difference there?
Yeah.
Yeah. You don't multiply by 2. You don't multiply the length by 2 to get the area. You multiply the length times the width. So let's take the square root of 4.36. I'm just going to punch that in my calculator. You do the same?
Yeah.
Let me know what you get.
2.08.
Yeah. 2. Yeah, I'll just add it. 2.088. And be careful when you're rounding. I would round as little as possible. Maybe at the very end. When you need to. But like I'm just going to leave that number up in my calculator right now. So I don't even have to do any rounding on the calculator. Does that make some sense? Why you can just leave that in your calculator?
Yeah.
Yeah. Just so I don't have to write the whole thing out. I'm just going to round it sort of on the whiteboard. But I'm leaving that number on the calculator. Okay. So now we know the length and the width in terms of miles. And now we can convert those miles into yards. Does that make some sense? Why we can do that?
Yeah.
Yeah. And then once we know the length and the width in terms of yards, we can find the area in terms of yards by multiplying the length and width in terms of yards. Okay? So we're going to do that conversion unit thing again that we just did. It's 2.088 miles. We're going to multiply by this fraction. We want to go into yards, so we put in yards in the numerator, or we put in yards in the denominator?
Numerator.
We're putting yards in the numerator. Absolutely. Put miles in the denominator. Okay. And then they give us the unit conversion basically right here. 1 mile is 1,760 yards.
Mm-hmm.
So I'm going to put 1 mile in the denominator, 1,760 in the numerator. And now we can convert the miles to yards. Miles cancel out. And I'm just leaving that big 2.088 number up on the calculator, multiplying that by 1,760. You go ahead and do the same. Tell me what you get.
3,674.
I totally punched in something wrong. Hold on. 8 times.
Maybe.
Yeah. Okay. Yeah. You got 3,000.
Yeah.
Tell me again.
3,674.
3,674. Like 0.88, something like that.
Yeah, 0.98.
0.98.
Mm-hmm.
Here we go. Yards. Okay. And then the same thing here for the length. 0.98. Awesome. We take that number and we can square it, and that should give us the area in yards. Does that make sense?
Yeah.
All right, let's square it. What do we get?
13,505,506.
That's a yeah, that's a big number. 13 million. But what's the right answer? Look at the answers.
D.
It's got to be D. And it is. Questions about that, or does that make sense?
No, that makes sense.
Yeah. Yeah. And that does make sense logically, too. If it's 4.36 square miles, I mean, that's a good-sized town. I mean, that's a lot of area. It's going to be a lot of yards. You know, even if you're just guessing here, I'd guess one of the bigger numbers. A and B don't make a ton of sense logically either. Does that make some sense why you can kind of get rid of A and B logically, even if you didn't know the calculation?
Yeah.
Yeah. If you know how big a yard is in comparison to a mile, I mean, it's got to be a huge number. So even if you're just guessing here, I think you have a 50-50 chance really between C and D if you're thinking about the question clearly. Questions about that? Or are we good?
No, we're good.
Okay, great job. Not an easy question, but if you draw a picture, you're just much more likely to think about it the right way. Ooh, this is a tricky question here. All right, go and read question 24 for us, please. Tanner.
Okay. For line H, the table shows 3 values of X and their corresponding values of Y. Line K is the result of translating line H down 5 units and the XY plane. What is the x-intercept of line K?
What in the heck are we solving for you, Tanner?
The x-intercept of line K.
The x-intercept of line K. This is a tough question, man. This is a tough question. Okay. And the path here is just not obvious at all. But I think we're going to have to figure out, here's what I'm thinking right now. We're going to have to figure out what the equation for line K is. Okay? I think we're going to have to figure that out. Well, in fact, I think first we're going to figure out what the equation of line H is. Right? And they give us enough information here because they give us a chart here with these X and Y values for line H. Right? These values are for line H. Is that clear?
Yeah.
Yeah. And so we can use that. We can figure out what the slope of that line is in like y equals mx plus b terms. We've talked about y equals mx plus b. You're familiar with that?
Yeah.
Yeah, where m is the slope and then the b is the y-intercept. Once we know the slope, we can calculate the y-intercept pretty easily. I'll show you how to do that here in just a minute for line H. But then line K isn't the same. Line K is translated down 5 units. So we're going to have to shift that down to 5 units. I'll show you kind of what that means and how to think about that here in just a minute. But once we can translate that down 5 units, then I think we can figure out what the y-intercept of line H is, and then therefore what the x-intercept is as well here in just a minute. There's a lot of steps here. This is a tough question, man. This is one of the tougher ones, maybe the toughest we've done so far. But first, let's come up with the equation of line H. So we'll start there. Okay. Do you have any idea how to use these values they give us and calculate the slope of line H? Do you have any idea how to do that?
It's been a while since I've done it.
Well, what does slope mean? Let's start there. What does slope mean? There's a couple ways to think about it.
The angle of the line going through.
Yeah, you could think about like the angle of ascent or descent, right? Ascent going left to right if it's a positive slope, or descent if it's going down left to right. You can think about it in those terms. You can think about it in terms of the rate of change. If we're talking about some change over time or something like that. You could also think about it in terms of the rise over the run. How much you're going up divided by how much you're going over. Is that familiar?
Yeah.
Yeah, and I've got a section there on the rules and basic concept D. No need to look at it right now, but you can reference that if you see a question that involves slope and you're practicing this on your own. So if we just figure out how much we're going up and how much we're going over in this line, which we can figure out, I think, just kind of logically, then we can calculate the slope pretty easily. I know some students like there's a slope formula. It's like y2 minus y1 over x2 minus x, but everybody mixes up their x1 and y1 values, and it's easy to screw up if you're thinking about a formula. Just look at those 2 points I circled. Okay, the first 2 points.
Okay.
And when we're going from basically 130 on the y-axis to 160, how much are we going up on the y-axis? From 130 to 160.
Just 30.
Yeah, we're going up 30 units. Does that make some sense?
Yeah.
That's our numerator. That's our rise. And if we divide that by the run, how much we're going over on the x-axis, we'll get our slope. Now look at the x values here for those 2 points. We got 18 and 23. How much are we going over from 18 to 23? How much are we going over?
5.
5 units. We know our slope. It's 30 divided by 5, which is what?
30. I mean 6. Wow.
Yeah, 6. Yeah, 30 divided by 5 is 6. So far we know the equation of this line is y equals 6x plus b. We don't know our b value just yet. We're going to figure that out in just a minute. Does that make some sense why we know that's at least part of the equation of line H?
Yeah.
Okay. Now, we're going to need to calculate the b value. This is the y-intercept of this line H. How do we do that? Well, here's the deal. They give us a bunch of x, y values in this chart. So I'm going to take these first 2 x and y values just because they're the smallest values, and this is going to make this a little bit easier. If we plug in those x and y values into this equation that we formulated here, we've got a value for y, that's 130. We get a value for x, that's 18. Once we plug in those values, we can solve for b just algebraically, just isolate b, and then we'll know the y-intercept of line H. Does that make some sense?
Yeah.
Okay. Let me see you plug in those values, and then we'll solve for b here. Let me see you work this out. So you're plugging in 130 for y. You're plugging in 18 for x.
130 equals 6 divided by 5. 18, did you say?
Yep. X is 18. Yeah, I'm just drawing those values out from the chart. Okay. And that's a B. Sorry, not a 6. Is that what your B's look like? Is that a B?
Oh no. Sorry, I thought that
yeah,
a B.
Let me make it. I'll make it real clear. There you go. Or more clear. Yeah. Okay. All right. So what's 16 times 8? Just punch that into the old calculator. Again, you've got access to the calculator all the way through this test. It's going to make life a little easier.
$180.
180.
No, wait. Maybe.
Is that right?
Yeah.
Yeah, 180. Okay, that sounds right. No, that does not sound right. Hold on. I'm punching in right now. 6 times 18. 108. 108.
Oh, yeah.
108.
Oh, that wrong.
Okay. I'm just going to rewrite this here. 130 equals 108 plus b. How do we solve for b now? This isn't too bad.
We find the difference between 130 and 108.
Yeah, just subtract 108 on both sides. I'll work it out. What's that give us?
22.
22. So the b value is 22. So now we can plug that back into the equation up here. And here's our equation for line H. It's y equals 6x plus 22. Does that make sense why that's our equation for line H?
Yeah.
Okay. That alone is very involved. Okay. Very involved. We still haven't found the right answer yet. We don't even know the equation for line K yet. We're going to figure that out here in just a minute. Okay. Now notice they say that line K is the result of translating H down 5 units on the XY plane. Does that make some sense? What that means?
Yeah.
Yeah. We're just shifting it down. So interestingly, line K is going to have the same slope, right? Because it looks like the same line. Like the angle of its ascent or descent is the same. The slope is the same. But it's going to have a different y-intercept. Because it's going to be shifted down 5 units. Do you know, like right now, what the y-intercept of line K is, this new line, shifted down 5 units? Do you know what it is? Just logically? Maybe, maybe not. You can say no if you don't.
I don't think so.
Yeah. I want to go to the rules real quick, because I've added this section here. On the digital SAT, I've seen, well, this question here on translating lines up and down on the y-axis. I've seen a couple of them. So I want to go to basic concept D. Okay. And this is like the 6th bullet point in basic concept D. 6th bullet point. A lot of graphing questions on the SAT. It says for the line y equals 2x plus 5. I want you to read that bullet point for us, please.
For the line y equals 2x plus 5, shift it down 4 units. The new line is y equals 2x plus 1.
All right, I'm going to stop you real quick. I'm going to stop you real quick, Taylor. Yeah. Take a look at that. Does that make sense? Why, if we're shifting that line down 4 units, that line y equals 2x plus 5, does it make sense why the y-intercept is basically going to be going down by 4 units?
Yeah.
And that's it.
Yeah.
That's it. You're basically subtracting the shift from the y-intercept. That's all you're doing. Does that make sense why that's the case?
Yeah.
Yeah. Keep reading.
If the line is shifted up 4 units, the new line is y equals 2x plus 9.
Yeah. Does that make sense now why the new y-intercept is 9 if we're shifting it up 4 units from 5?
Yeah.
You're just adding 4 to the y-intercept. Okay. Well, let's go back to the question. I think you see it now. If our current line is y equals 6x plus 22, and we're shifting that down 5 units, what's the new y-intercept for line K?
17.
It's going to be 17, which is 22 minus 5. So here's the equation for line K. Y equals 6x, same slope, plus 17. That's line K. Does that make some sense?
Yeah.
Okay. Just going to refresh my whiteboard here. Woo. There we go. There's our equation for line K. Okay. All right. Let's go back to the question now, because we still need to find the x-intercept of line K. Okay, that's the question. What's the x-intercept of line K? So let's talk about finding the x-intercept. Okay, let's talk about finding that x-intercept. My first question for you is, do you know the y value of any line, the y value at the x-intercept? Do you know what it is? Or no? It's the same for any x-intercept.
Typically 0.
Yeah, not just typically. It's always 0. It's always 0. Let me make this really clear. I'm going to draw a little xy axis. Here on, actually, I'm going to use the grid lines here. I'm going to draw a little xy axis. There we go. That's better. And let's say we've got a line like this one. Woo. Okay. And the x-intercept, of course, just means where the line hits the y-axis, or the x-axis. That's the x-intercept. So that's the x-intercept is right there. It's the point, that is the point 8, 0, where the x value is 8, the y value is 0. Does that make sense? Do you see where my little xy axis is? Just below the question?
Yeah.
Okay. So I don't care what line you draw. Any line you draw, wherever the line hits the x-axis, the y value is always going to be 0. There's no way around it. So when they're asking for the x-intercept of line k, basically all we're doing is plugging in a 0 for the y value. Okay. Now, of course, the line that I drew isn't the same line as the one in the question here. But no matter what, if it's the x-intercept, the y value is 0. So all we got to do is plug in a 0 for y and then solve for the x value. We'll have the x-intercept of this line k. Does that make some sense?
Yeah.
Okay. I'm going to clear some space here. I want to see you plug that in. Plug in that 0 for y and let's solve for x. Love it. It's looking good.
And we want to get to 0. So wouldn't x be a negative number in that case?
Yeah, it's going to have to be negative, yeah.
Yeah.
But let's just go through the process here. What are we going to do to both sides to get x alone?
Subtract.
Yep.
17.
Yep. Looking good.
And that is going to be negative 17 equals 6x. And then divide by 6 on both sides.
Yep, looking good. And we got it.
X equals negative 2.8.
Yeah.
30.
You could even just leave it as this. I mean, the 6's cancel out, and you could say x is negative 17 over 6, which I think makes sense because look at the answer choices, right? The x values are all in fraction form.
Oh, yeah.
Does that make some sense?
Yeah.
Okay. But I think you see the right answer now. Do you see it?
Yeah.
What's the right answer?
D.
It's got to be D. It is. Woo! That is a tough question. That's tough, isn't it?
A little bit, yeah.
That's a little bit. Now, again, if you know the concepts, you can kind of see the path. You're like, okay, I can just figure out what and let's step back. See what the path is here. We got to figure out what the equation of line H is. Then we figure out the equation of line K is. Once we know the equation of line K, then we're just plugging in a 0 for y to find the x-intercept. So it's really just kind of those 3 steps. But you got to kind of know what all those concepts really mean, kind of how to navigate your way through that. There's a path. That's a tough one. Might be a good question to skip on a time test, just because even if you kind of know what to do, it takes a lot of time. But still practice this because I see these concepts pop up in a lot of different ways in a lot of different questions. So really know these concepts. But if you know what things mean here, there's a path. Questions about this one?
No.
Okay. Just a few more here in Module 1. Oh, this is a tough one too, man. They do get tough here at the end. They really do. All right, go ahead and read question 25 for us when you see that on the whiteboard.
Yep. In the xy plane, the graph of the equation y equals minus x to the second power plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c?
What are we solving for here, Tanner?
The value of c.
Yeah, the value of c, which is part of this equation right here, y equals c. Okay?
Yeah.
So we've got a parabola and we've got a line. Okay? And they're intersecting at 1 point. I want to start by just kind of conceptualizing this question the right way, just kind of thinking about what all this means. And I'm going to start by drawing a picture here. I'm going to draw a little XY axis just to the right of the question.
Yep.
Okay. Got a little XY axis. Now we've got this parabola. Notice that the A value of this parabola, and the A value, that's the coefficient in front of the x squared term. If you got the equation, you've seen this before, right? If the equation is in y equals ax squared plus bx plus c form. If that a value is negative, in this case the a value is -1. If the a value of a parabola is negative, do you know how that affects the shape of the parabola? Are you familiar with this?
No.
No.
I don't.
Well, here's the deal. Here's I'm going to show you roughly the graph of the equation y equals x squared.
Okay.
Okay, let me explain this. This is roughly what it's going to look like. Not exactly, but roughly what it's going to look like. It's going to go up like that. Woo! Okay. Which should make a ton of sense because, like, no matter what y is, or no matter what x is, the y value is going to be positive. Does that make some sense why the y value is going to be positive? I guess it could be 0 as well if x is 0. But if x is anything above 0, the y value's got to be positive because you're squaring it. Right? So if x is positive, of course, you're squaring it, you're going to get a positive number for y.
Mm-hmm.
But even if x is negative, you're squaring it, you're going to get a positive value for y. Does that make sense why, if x squared is positive, or, here the a value would be 1 in front of x squared. If the a value is positive, you're going to get a positive value for y if it's just y equals x squared. Does that make some sense?
Yeah.
Okay. Now let me show you. I'm going to change a little bit. Let's make it y equals negative. That was a really ugly negative sign. Hold on. Just fix this. Let's make it negative x squared. Okay, so now the a value is negative. It's going to be a very different looking graph. It's going to go like this. Roughly. It's going to look like that. Because still, x squared is going to be positive. No matter what x is, x squared is going to be positive. But because that negative sign, we're going to have to flip that positive sign and make it negative. So you're going to have nothing but negative values. Again, x could be 0, so y could be 0 there. But other than that, any x values are going to give you a negative y value. Nothing but negative values. Does that make sense why having a negative a value is going to make the graph go down like that? It's going to open downward. Does that make some sense?
Yeah.
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 And here's how I remember. This is really stupid, but it kind of works. Like if the a value is positive, then you get a happy face. Smiley face. Parabola. And if the a value is negative, you get a frowny face. Parabola. Like this one right here. It's going to be a frowny face parabola. Does that make sense?
Yeah.
Okay. So here we have a negative a value in this question. So is this opening up or down? Is this smiley face or frowny face parabola in this question?
Smile.
No, it's negative. The a value is negative.
Oh.
In the question.
There.
Right? Do you see that?
Oh, yeah.
Yeah.
So, right. The negative.
So
it's going to be
so negative
the face.
It's going to be frowny face. Is that clear?
Yeah.
Yeah. Okay. All right. So I don't know exactly what it looks like. It might look something like this. I don't know. I don't. Yeah, something like that. But it's going to be some frowny face parabola. It could be up here. I don't know. We could graph it here in just a minute. And by the way, on the SAT, they give you a graphing calculator. I mean, if you have a graphing calculator, you can graph it as well. Do you have access to a graphing calculator by any chance?
Yeah, I do.
You do? Okay. Punch in the graph of that equation, the one that gives us in the question real quick. I'm just curious to see what you get. They say they give you a version of like the online Desmos calculator. Do you ever use Desmos? Are you familiar with Desmos?
No, I'm not.
It's just an online graphing calculator. And they give you a limited version of the Desmos calculator. So even if you don't bring in a graphing calculator on the SAT, you can still graph equations if you want to. We're going to do it without it, but go and graph that. Did you get a frowny face parabola for that equation, or are you still punching it in?
Still punching it in.
Go and punch that in. But it should be frowny face.
Yeah, it's frowny face.
Yeah. And then does that go above the x-axis at all, or no? Or well below the x-axis.
It's below.
It's below. Yeah, that's what I thought, because looks like the y-intercept is negative 100. So it's going to be something like this. Woo. That kind of parabola. I don't know exactly where. But notice now there's something else we got to draw out from the question here, which is that the line y equals c intersects that parabola at exactly 1 point. And that's code for something very specific. That line is going to be touching basically the parabola at its vertex, something like that. If it's intersecting at only 1 point, it's got to be touching its vertex, the highest point on that graph. Does that make some sense why if it's only intersecting at 1 point, exactly 1 point, it's got to touch the vertex? Does that make a little sense or no?
Yeah.
Yeah, I mean, if it was intersecting somewhere else, it would hit at 2 points, like right here. Like literally any other points of intersection, there's going to be more than 1 point, but only at the vertex, it's intersecting at 1 point. So we know the y value at that point is basically the y value of the vertex of that parabola. Does that make some sense?
Yeah.
Yeah. Yeah. So, by the way, if you just graph it, you might be able to like kind of find the y value of the vertex on your graphing calculator. In fact, do you know how to do that? Like using the trace function?
No.
No. Okay. There's a way to do it that way. Just literally look at it and see what the y value of the vertex is. That could give you the right answer here. Anybody watching the recording can test that themselves. I'm going to show you the sort of the algebraic operation here. There's another way to do it. There's a formula for finding the x value of the vertex. Let me tell you what that formula is. That formula is negative b over 2a. And I've got a section here on the cheat sheet as well, but I'll just give this to you right now. This is worth knowing because this pops up. I've seen it on a number of SAT questions. This is the x value of the vertex, negative b over 2a, if we've got an equation in ax squared plus bx plus c form, which we do have. Does that make some sense where we can get our a and b values from using this equation? Does that make some sense?
Yeah.
Okay. So if we can calculate the x value of the vertex, which we can, it's just negative b over 2a, then we can plug in that x value of the vertex back into the equation and we'll get the y value of the vertex. Does that make some sense?
Yeah.
Okay. So let's calculate the x value of the vertex real quick. First, what's our a value and what's our b value from this equation?
A value is 9x.
No, that's the b value.
Oh,
9 is the b.
so 100 is our A value.
That's our c value. That's our. Hold on. Let me make it real clear too, in case it's not obvious for anybody watching the recording here. Here's the form: ax squared plus bx.
Oh, right.
You see it now? Yeah. So our a value is the thing we're multiplying x squared by. And what do we multiply x squared by? Some students might look at that and be like, oh, we're not multiplying by anything. We're multiplying by 0. But we're not. What are we multiplying by? What are we multiplying by?
1.
Not 1. We're multiplying by
negative 1. Yeah.
Negative 1. Is that clear now?
Yeah.
Yeah. You got to be able to draw that out from the equation. The a value is negative 1. And what's our b value? We just mentioned it.
9x.
Yeah, I wouldn't say the b value. Yeah, just the b value is 9. That's the thing in front of the x. Not 9x, but 9. So our a value is negative 1. Our b value is 9. We can calculate negative b over 2a now pretty easily. Okay? Let me see you do that on the whiteboard. Let me see you just plug those guys into negative b over 2a. We'll get the x value of the vertex.
Negative 9 over 2 by negative 1.
Yeah. And be careful there because that looks a little bit like 2 minus 1. So I'm going to put parentheses there on that negative 1.
Oh, yeah.
Does that make sense? Yeah.
Yeah.
So what's the x value of the vertex? You just leave it as a fraction, honestly.
Yeah.
What is it?
1 second. 2. It's 4.5.
Yeah, 9 over 2 or 4.5. Let's do the decimal here. I think it's going to make life a little bit easier, actually, if we make it 4.5. Yeah. Mm-hmm. So I'm going to label that as well. That's the x value of the vertex. Okay? Does that make sense?
Yeah.
Okay. So now we can calculate our y value of the vertex by plugging in that 4.5 into the equation for x right here. And then we'll just calculate what the y value is. Does that make sense why that'll tell us what the y value of the vertex is?
Yeah.
Okay. That's a little bit tricky. You're kind of keeping all the decimals straight. You could do a fraction here as well. I'm going to work this out. Do you mind?
Yeah.
I'm just going to work. I think it'll be faster and easier if I kind of work it out on the whiteboard. Yeah, I'm going to do it as you could do it as a decimal, punch it all in the right way. I'm going to do it as a fraction here because the answers are in fractions. So if I plug in that x value, we're going to get y equals negative 9 over 2 squared plus 9 times 9 over 2. You see where I'm here on the whiteboard?
Yeah.
Minus 100. Oh, there's a lot going on here. It's going to be ugly. This is so ugly. Again, punching your calculator is probably easier. But we can practice operations here with fractions. So 9 over 2 squared, that just means 9 over 2 times 9 over 2. Is that obvious?
Yeah.
Yeah. So that's going to give us negative 81 over 4. Does that make sense?
Mm-hmm.
Plus 81 over 2 minus 100. And then I'm gonna add these two terms here together, but I got to have a common denominator to do that. So I'm just going to turn 81 over 2 into, I'm going to multiply by 2 over 2. So that'll give us 162 over 4 minus 81 over 4 minus 100. And then I'm going to actually express 100 with a 4 in the denominator as well. What would 100 with a 4 in the denominator be? Do you know what it would be?
That would be 25.
Oh, that's 100 divided by 4.
Yeah.
But remember, we'd have to multiply by 4 over 4, basically.
Oh, yeah.
Right. So that should give us 400 over 4. Does that make sense?
Yeah.
Okay. Now we just add these numerators together. I'm going to use the calculator here now. Go and work it out on your end as well. So it's 162 minus 81 minus 400. Woo!
Negative 319.
That's what I got. Yeah, negative 319. And then our denominator stays the same, but denominator is still 4. That should be, good heavens, the y value of the vertex right there. Oh, there it is. C. Yeah, answer C. Woo, doggy. That's a tough question. That's tough. Do you think it would be easier to just punch in that 4.5 in for x and kind of punch it into the calculator? Do you see a path there? Deal with the decimal?
Yeah.
Yeah, that would work as well. That would work. And then once you get the decimal, you might be like, but yeah, but my answer is a decimal and none of the answer choices are decimals. You turn them into decimals. You can just divide them, and you got a decimal there. You could do that as well. But any path works. Any path there works. But let's step back from it and talk about the overall path here for finding this. You just got to realize that you're looking for the y value of the vertex. That's what C is. It's the y value of the vertex. Once you know that, just use your negative b over 2a formula to find the x value of the vertex. Once you get the x value, plug that back into the equation, find the y value of the vertex. Any questions about that?
No.
Okay. Tough question. They get tough here at the end. You see it now, right? You see it.
Yeah.
That's a tough question. But some concepts there worth knowing. That could apply to some other questions. So maybe a good one to skip on a time test, but still good practice. All right. Oh, man, this one's tough, too. Some really tough questions here. Go to read question 26 for us, please, when you see that on the screen.
Okay. 2x plus 3y equals 7. 10x plus 15y equals 35. For each real number R, which of the following points lies on the graph of each the equation in the xy plane for the given system?
What? What are we solving for here, Tanner? What are we solving for with this question?
We are solving for the following points that lie on the xy plane.
Yes.
With the equations.
Yep. Which points lie on the xy plane for each equation in the given system? Okay. And if you look at the answer choices, they give us a bunch of answer choices in terms of R, which is really annoying, really kind of confusing. We're going to create a value for R, and that's going to simplify this as much as we can simplify it. Okay, but we'll do that in just a moment. But first, I want to point out, take a close look at these two equations here in the question. What's really kind of funky about this question is that, yeah, they give us this system of equations, but these two equations are equivalent forms of the same equation. It's the same equation. It's just they've multiplied the top equation by 5 on both sides to get the bottom equation. Does that make some sense?
Yeah.
Yeah. I mean, if you take a look at that, you multiply both sides of that top equation by 5, you'll get the bottom equation when you distribute that 5. So really, it's the same. I mean, like, we'll just find out which point is on the graph of just like, we'll just do the top equation. We don't even have to worry about the bottom equation. Just the top equation is all we need here. Because it's the same equation. The top equation is just a more simplified form of the bottom equation. Does that make sense?
Yeah.
Okay. Let's create a value for r. Okay, just to simplify this question. I'm going to make r equal 0. Okay, other values would work, but 0 is just going to make the arithmetic really easy, at least to start. Okay. And if we plug in a 0 for r into the answer choices, we're going to get some xy values for each of these answer choices that are just going to be easier to deal with. And I think maybe you're starting to see why we're plugging in a 0 here for r. Because if r is 0, we can express these xy values for answer choice A in a lot simpler form. How can we express answer choice A if r is 0? Do you see what that's going to equal if r is 0?
Yeah.
What's that point going to be in terms of x and y if r is 0? What's that point?
It's going to be 0, 5, right? Or is it going to be the other way?
Well, if we plug in a 0 for r, we get 0 divided by 5 plus 7.
All right.
What's 0 divided by 5, Tanner?
0.
0. What's 0 plus 7?
7.
7.
Oh,
so if r is
yeah.
0, right? The x value is 7.
Oh, yeah.
Does that make sense?
I see.
Let's do the same thing with the other r. That's just 0. So what's the y value for that point?
Is going to be 35.
35, yeah. It's just 0 plus 35. That's it. It's a little bit, there's a lot to sort of process visually here. I mean, do you see the comma here separating these XY values and these ordered pairs? Is that clear now?
Yeah.
Yeah, it's a little bit tough to process visually because there's a lot going on there. But if r is 0, then we can just say, okay, well, then the point 7, 35 needs to be on the graph of that line. Does that make sense?
Yeah.
Okay. Let's do the same thing here with all the other answer choices. We're going to draw out the x and y values when r is 0. So we'll do the same thing with answer choice B, and we'll test these here in just a minute. But let's make r 0. So what's the first point, the x value for answer choice B?
It's going to be 0. And 7 by 2. Going to be 3.5, comma 0.
Yeah, 3.5.
Negative 3.5.
No, it's going to be positive here.
Just 3.5?
Because that right there, negative 3 times 0 is just 0.
Yeah.
That's going to be 0 right there. So it's 0 plus 7 over 2. So we could leave it as a fraction, but we could do it a decimal too. Doesn't matter. We just do 3.5. That'll work. 3.5 comma 0. That's the point on the line if r is 0. Does that make sense?
Yeah.
Okay. Let's do the same thing for answer choice C. What's our x value for answer choice C?
0.
And what's
comma. And 0, comma 2.33.
3 repeating. Yeah, I'm just going to leave that as the fraction, 7 over 3. It's the same thing. Just so we don't have to worry about rounding.
Yeah.
And then answer choice D, what are our x and y values?
0, comma, with a 3.5.
3.5.
As the
Yeah, absolutely. Does that make sense?
Yeah.
Okay, good. Now we can plug in these x and y values into the top equation. The right answer has to give us a true statement for these values. If r is 0, which it is. We set that value. So let me see you plug in 7, 35 into we'll just plug into the top equation again. We don't have to worry about the bottom one. Plug into that equation. And let's see if we get a true statement.
Sorry, my thing's being a little slow.
You might need to refresh your whiteboard.
Yeah. So we're plugging in Sorry.
Yeah, so we're plugging that 0.7 comma 35. So x is 7, the y value is 35. We're plugging into the top equation. Yep. Looking good.
5, and then what's that one? 35. Or was that different?
It's 3 times 35, right? The coefficient in front of the y is 3.
Oh, yeah. So y is 3. Oh, just erased.
Well, y is still 35. Why? Where's this 5 coming from?
The top equation.
I think it's 2x plus 3y.
Oh,
right?
3.
So we're multiplying 35 times 3. Yeah. Does that make sense?
Yeah. Ooh,
yeah. That'll work.
35.
Yeah.
And that would be.
Now, yeah, the equation says it gives us 7. Is that going to be 7, dude? Is that going to be 7?
No.
You know, it's not going to be 7. Yeah, I wouldn't even, like, just looking at that, I'm like, dude, that's not going to be 7. That's going to be a big number. It is. You can stop there. We're good. Answer choice A is gone. It doesn't work for those values. Does that make sense?
Yeah.
Let's try answer choice B. And again, we're just plugging in now. We're plugging in 3.5 for x and plugging in a 0 for y. And seeing if we get a true statement.
Yeah.
I'm going to add some parentheses here just to make it real clear. I love parentheses. I really recommend them. Just kind of helps me keep my multiplication distinct from the other operations there. Oh, that's looking good. Okay, true statement, right, for B? True statement.
Yeah.
Okay, all right. Try answer choice C. I'll clear some space. We'll keep B, though. We got to test them all. We can't just stop here. It might be B. I don't know. But it could be something else as well. Plug in answer choice C.
Oh, yeah. Plug in answer choice C. 2 multiplied by 0 plus 3 by.
And you just leave it as a fraction here because those 3's are going to cancel out, I think.
Yeah.
3 times 7 over 3, right? You see what that's going to equal? You see why those 3's cancel out? Yeah. What does that give us?
That is going to give us a 21.
Well,
that's our answer.
21 over 3. Right, if you're just multiplying the 3 times 7 over 3, right? Because that's the same as 3 over 1 times 7 over 3. But I was saying you could cancel out the 3's and you get 7 over 1. Does that make sense?
Yeah, it's going to be 7.
So be careful there, yeah. But that is 7. So that's a true statement as well. So I don't think we can, both B and C give us true statements. So we can't confirm that it's B, not yet.
Yeah.
We can't. It could be B or C. What about D? Let's plug in those values for D. But I don't think that's looking promising. Good. I'm going to add those parentheses. That's not 7, is it?
No.
Nope. All right. So we know it's not D. If this is as far as you get, you got a 50-50 chance on a very tough question. That's a good start. I'll take it. All right. Let's see if we can find if we can determine between B and C right now. But we're going to have to plug in another value for R. Okay, I wish there were an easier way to do this. This is still the easiest way to solve this question. It really is. I'm going to plug in another value for R. We're going to make R equal 1. Okay? Now, we still don't have to worry about answer choice A and answer choice B because those values didn't work when R was 0, so we don't even have to worry about A and D. It's just between B and C. But now we have to calculate the new X and Y values when R is 1. So I'm going to plug this in just to make it a little bit faster here. I'm going to plug in the 1 for R and help me calculate it. But if we do that for answer choice B, we get negative 3 times 1 over 2 plus 7 over 2, comma 1. Does that make some sense?
Yeah.
Okay. And then that's going to be negative 3 over 2 plus 7 over 2. What does that equal? Do you know?
That is going to equal 4.
In the numerator, yeah. 4, and so 4 over 2.
4 over 2,
right?
yeah.
Does that make sense when it's 4 over 2? So that's our
Yeah,
X value. Yeah, that's our X value for answer choice B. So I'm going to just put 2 there for the X value. And then the Y value, the Y value I already know, it's 1, right, if R is 1. So 2 comma 1. Does that make some sense?
Yeah.
Okay. I'm just going to clear some space. Let's get our X and Y values for answer choice C. I'll plug it in real quick. If R is 1, it's going to be 1 comma, and then 2 times 1 divided by 3 plus 7 over 3. Oh, I think I know what that's going to be. It's just 2/3 plus 7 over 3. What's that equal? Do you know what that equals?
9 over 3.
9 over 3, which is what?
3.
Just 3? Yeah, regular 3. So it's going to be 1 comma 3. Okay, great. This isn't too bad now. Let's plug those values in, those X and Y values. And let me see you do this. Plug those into the top equation. Let's see if those give us a true statement.
Okay.
Looking good. Looking very good.
Yeah, 4 plus 3 equals 7.
Oh, that works. That works. All right, so we'll keep B. Let's try answer choice C.
Okay.
Looking good. But I don't think this is going to work.
Yeah.
That's not. Yeah, that's going to be 11. So we know it's not C. Woo! We can confirm answer choice B.
Oh. There we go.
Yeah. Questions about that?
No.
That's a tough question. That's a really tough question. Because even if you know how to solve it, like, it's just so involved. That's a really tough one. I mean, just be aware, when you're taking the digital SAT, there's going to be some questions at the end that are very high level difficulty questions. And, if you're pressed for time, it might make sense to, if you find yourself spending more than like a minute and a half or 2 minutes just trying to figure out what's going on in the question, it's a skip. And that's one of them here, I think. You got to get to the questions at the end that you can solve for sure. But this one, man, this is like a time trap. This question really is. So I would probably recommend skipping a question like this if you saw it. But I want you to know how to solve it, and still good practice and plugging in values and good practice on the arithmetic there. Just kind of figure out what things mean in the question. So it's worth covering. We got one more question here on Module 1. One more question. I think it's a little bit easier. Well, let's do it. I think it's a geometry question, if I recall correctly. All right, go ahead and read question 27 for us, please.
Okay. The perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is K.
Times the square root of 3. That's how I'd read that.
Times the square root of 3. Yeah. Sorry, it was being weird. Centimeters where K is a constant. What is the value of K?
Oh, my goodness. What are we solving for here, Tanner?
What is the value of k?
What is the value of k, right? And we know the height of the triangle is k times the square root of 3 centimeters. So basically, we're going to have to find the height of this triangle, okay? And then once we know the height, I think we can figure out what k is, because it'll probably be in terms of the square root of 3, okay? I'll explain kind of what that means here in just a moment. But first, let's follow that third rule, and let's draw a picture of this triangle, okay? It's an equilateral triangle. Do you know what that means? Let's talk about that term first. What does that mean?
All the sides are equal.
All sides are equal. So draw me a triangle here. Just below the question. Draw me a triangle where all the sides are equal. Let's see what this looks like.
Try to. Oh.
If you need help with the triangle, I can help you out as well. It's a little tricky.
Yeah.
I might help you out, Tanner. Can I help you out? Can I help you out a little bit?
Yeah.
Let me draw it. For you.
I'm struggling.
You're good. All right, I think I can do it. But I hope I can do it. Okay, here's a triangle. Something like this. This ain't perfect, but it should work. There we go. That's actually decent. Okay, that'll work. There's our equilateral triangle again, where the sides are equal, and that's more or less the case there. Okay. And we know the perimeter of this equilateral triangle is 624 centimeters. You know what perimeter means? Let's talk about that.
It's the area around.
Well, I wouldn't use the term area, but I'd say the length.
Yeah.
All the way around, right? If you add up all the sides, basically this triangle, you're going to get 624. Now, because this is an equilateral triangle where all the sides are equal, I think we can easily calculate what the lengths of each of these sides of this equilateral triangle are. You know what I'm saying?
Yeah.
Yeah, how can we do that?
Divide 624 by 3.
Yeah. That'll do it. Let's punch it in to the calculator.
208.
208. That sounds great. So each side, I'm going to make a note of that as well. Each side is, we're doing it. Each side is 208. Love it. Okay. Does that make sense so far?
Yeah.
Okay. Now we got to figure out what the height of this triangle is. Let me draw the height here. This would be the height. And just this like dotted line here. That's the height. That's our H value. The height of that triangle. Now, I don't know if this is obvious or not, but do you know the angles in an equilateral triangle? Are you familiar with this? We should know what the angles are.
Yeah.
What are the angles in an equilateral triangle? Do you know the values?
They are. Oh.
Well, think about it this way. Every triangle has how many degrees?
Yeah. 180.
180. And all the angles in an equilateral triangle, just like all the sides, all the angles are equal as well, right? Right?
Yeah.
So what are the angles?
60.
60 degrees all the way around. All of them are 60. And it's darn helpful to know that for this question. The reason why is if we cut this triangle in half, basically that's the height value right there. We're bisecting this 60-degree angle here, which is going to give us two 30-degree angles on each side of the height. Does that make sense?
Yeah.
Which gives us a special kind of right triangle called a 30, 60, 90 right triangle. You familiar with 30, 60, 90 right triangles?
No.
Let's go to the beginning of that practice test, the beginning of Module 1. I want to go there real quick. I'm going to show you this is. Here they give you this formula. Okay, so go to that document. And this is on the right-hand side of the formula page. You should see a little section. They say special right triangles. Okay?
Yeah.
And they've got two of them there, two special right triangles. One's a 30, 60, 90. And another's a 45, 45, 90. Okay.
Yeah.
Now, 30, 60, 90 right triangles have a special ratio of their sides. Okay? Like, if you know sort of like the smallest side of a 30, 60, 90 right triangle, that's the x value, by the way. The x value. Then the hypotenuse, the longest side, is just going to be twice that smallest side. Does that make some sense?
Yeah.
Yeah. And then the middle side, right, which I think would correspond to our height in this particular case. But that middle length here would be x times the square root of 3, whatever x is. So like if x is 1 in this case, then that smallest side would be 1. The hypotenuse, the longest side, would be 2. And then that middle side would be 2 times the square root of 3 if x is 2. Does that make some sense?
Yeah.
Okay. Well, let's go back to the question here. We're going to need to know those ratios. Now, we know the hypotenuse of this 3069. I'm just going to draw it out to make it really clear. We'll just use this one here, this triangle here on the left-hand side. That's our 3060 right there. The hypotenuse is 208. So we should know the length of this smallest side. What's the length of that smallest side at the base? Remember, the hypotenuse is 2x, and the smallest side is going to be x.
Oh, yeah.
So what is that going to be? Should just be half of the hypotenuse.
Yeah.
Which is what?
1.
Well,
No.
but look we're back on the question now. We're back on the whiteboard.
Oh, right. Oh, half of 208. Sorry.
Half of 208. So what's that small side?
104.
104. Does that make sense?
Yeah.
Yeah. And so now we know the height of this triangle, right? Because it's just the small side times the square root of 3. So what's the height?
One second.
And I would just express it in terms of the square root of 3. I'll show you why in just a minute.
108 is... Wait, no.
So 104 is like the x value.
Yeah.
2x is 208. So I'll just show you here. It's going to be 104 times the square root of 3.
Yeah. That's what I did.
Does that make some sense? Why that's our height?
Yeah. Give me one.
You see where I am on the whiteboard?
Yeah.
Yeah. That's our height. Okay?
Yeah.
All right, so if 104 times the square root of 3 is the height, which it is, and they're saying the height of the triangle is k times the square root of 3 centimeters, then what's our k value?
K value is 104.
104. That's it. K equals 104. Woo! Questions about that?
No.
Got to be on the lookout for those special right triangles. All right, that's the case here. If you don't recognize it's a 30, 60, 90, it's going to be very tough to solve. I mean, I don't know how to solve it without making that recognition. But if you can recognize that we're dealing with a 30, 60, 90 right here, there's a path. You just got to figure out what your x value is. In this case, that's 104, and then the height's going to be 104 times the square root of 3, so k is 104. Woo! Questions about that?
No.
Tough ones at the end, man. Very different from the beginning of this test. On this module, they start to get really tricky probably around question 19 is when they start getting really tricky. So be aware of that. You do have to have time. If you're trying to get the highest scores, you're going to have time at the end to solve these. But be prepared to skip, I think, also. Because you don't have to be perfect on this test to get a good score. Just get the questions right you should be getting right, and you'll be good. But awesome. All right, that's it for Module 1. So if you made it all the way through this video, congratulations, first of all. And thanks for watching. Make sure to like this video. Please subscribe to my channel. And be on the lookout for more answer explanations for these new digital SAT practice coming out. Practice tests. I've got a video coming out for Module 2 on SAT practice test number 1 as well. So appreciate your help, Tanner. You've been awesome. Thank you so much. And thanks, everybody, for watching.